Hi, I'm Miss Berube, and today you're joining my Algebra 1 class. We're going to be discussing Chapter 8.2, Special Linear Systems, and I thought we would start off with a little bell ringer. Today's bell ringer is find the slope of the following equation. So our equation is 4x plus y equals minus 2. So, how do we find the slope? I'll give you a second. Right. Now that you've figured it out, let's see if everyone has the same answer. So, in order to get y by itself and get your equation in the y-intercept form, we're going to subtract negative 4x from both sides, leaving us with y equals negative 4x minus 2. So, if we follow our y-intercept form of the equation, we see that our m, or slope, is negative 4, and our y-intercept is negative 2. Once we've done that, you'll notice as we continue that isolating variables is very important. So now I would like to move on to another question, which is, which graph has more solutions in common? As you notice, you'll have 3 different graphs that I will pass out. Here's graph 1, in which you have the equation y equals negative 2x plus 7, the point 4 comma negative 1, the equation y equals 1/3 x minus 3. In graph number 2, you have the equation 3x plus 2y equals 6, and also the equation 3x plus 2y equals 12. Graph number 3, you have the equations y equals 2x plus 4 and 6x minus 3y equals 12. What I want you to answer and check with a partner is, which graph has more solutions in common? Try it now. Did you come up with a solution? Well, here it is, and get out your graphic organizers. Now that you've discussed your solutions with your partner, here are some key items for your graphic organizer. Plus, it will answer your question as to which graph has more solutions in common. Graph number 1 should go second. It has one solution because the lines intersect and are consistent and independent. Graph number 2 goes last. It is parallel lines and they have no solutions in common, or what we call inconsistent. And graph number 3 goes first. It is a line that coincides. They're actually the same line and have infinite solutions and are what we call dependent. Did you come up with a solution? Well, here it is, and get out your graphic organizers. Now that you've discussed your solutions with your partner, here are some key items for your graphic organizer. Plus, it will answer your question as to which graph has more solutions in common. Graph number 1 should go second. It has one solution because the lines intersect and are consistent and independent. Graph number 2 goes last. It is parallel lines, and they have no solutions in common, or what we call inconsistent. And graph number 3 goes first. It is a line that coincides. They're actually the same line and have infinite solutions and are what we call dependent. If we are not in class together, I will assign your partners via the internet. So, in keeping with our theme of special linear systems, I'm going to propose the following question. If you do not have your normal partner, I will be assigning one online, and you will perform the following task. On Tuesday nights, the Linear Bowling Alley offers a special called Bowlerama to encourage people to play lots of games. You pay a cover charge to get in and get bowling shoes, and then you only pay a little bit for each game you bowl. On Tuesday, Bo and several of his pals went to Bowlerama. At the end of the night, Bo knew that he had bowled 8 games and he had paid a total of $7.30. Tommy had bowled 11 games and paid a total of $8.35. Question 1. Write an equation that expresses the cost of playing at Bowlerama in terms of the number of games you bowled. Take a moment to figure this out. Continuing with number 2. Olivia wasn't sure how many games she had bowled, but her total bill was $6.60. Use your equation from question 1 to determine how many games Olivia bowled. Give you some time now to figure that out with your partner. Moving on, number 3. Liam said the next time they came, he was going to bring $10. Again, using our equation from question 1 to determine how many games Liam will be able to bowl. Try that now. And lastly, here's a bonus. On other nights when Bowlerama is not going on, it doesn't cost anything to get into linear lanes. Shoe rental is $1.50, and the cost per game bowled is $1.25. At least how many games must you bowl for Bowlerama to be a better deal than bowling the same number of games on any other night? Take a few moments. This is your possible first equation. C equals $4.50 plus 35 cents per game. So you may be wondering, how did we get that answer for number 1? Well, that's because we know that Bo had a cover charge plus 8 games for a total of $7.30, and Tommy had a cover charge plus 11 games equaling $8.35. So you may be wondering, how did we get that answer for number 1? Well, that's because we know that Bo had a cover charge plus 8 games for a total of $7.30, and Tommy had a cover charge plus 11 games equaling $8.35. In order to solve for C or G, I'm going to first give you the C values for both Bo and Tommy. You're going to start out with 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. When you substitute in 1, 1.5, etc., all the way to 4.5, you get the following values for games. Approximately 79 cents for 1. Approximately 73 cents for 1.5, and so on until you get to $4.50, which gives you 35 cents. And then you'll do the same for Tommy's equation. When you put in 1, you get approximately 67 cents. When you put in 1.5, you get approximately 62 cents. All the way until you get to $4.50, which you also get 35 cents. Which when we graph, you'll see why this is important. You've answered the question for Bo and Tommy and what their equation was, and you've graphed your equation, and you know that they coincide at the point $4.50 and 35 cents per game. We can now come up with an equation for question 1, which will answer all other questions. And just to get you started, that equation is C equals $4.50 plus 35 cents times G. In other words, the total cost equals the cover charge of $4.50 plus 35 cents per game. Now that you know that, you can graph all of your answers in table form and determine your final question, which is, are all of the graphs consistent, inconsistent, or continuous or discontinuous? The answers to these questions will be posted on your website. And thank you again for watching. Attached with this task will be a sheet to help you answer all of the questions. If you need more room, please feel free to use a piece of lined paper.